This video is for proportional relations notes. And so this is a pink page. The first thing that you need to do is to cut out and to sort all of these pieces. So put all your tables together, put all your graphs together. And so what we're going to do is we're going to sort them into two groups. They're going to either be proportional or non-proportional. So on a graph, if they're proportional, they will always go through 0, 0. They will always go through the origin. When you graph them, they'll always be a straight line. So if there's a curve, then you can automatically eliminate that from being proportional. When you're looking at a table, they're always going to have a constant ratio in the form of y over x, and that's going to equal k. And so what that k is the constant rate of change. It's your slope. And then equations are going to be in the form y equals kx. So there's nothing going to be added or subtracted to the end. So when we look at our tables, so if we look at this one right here, where x is 5 and y is 10, x is 8 and y is 16, what we can do is we can use that formula, that y over x. And so we can divide y by x. And so if you do that, get this thing turned on. All right, so if we do 10 divided by 5, I get 2. And then you want to do another point to make sure that it stays the same. So 16 divided by 8. And so if we do that, we get 2. And if we keep going down the list here and dividing y by x, we're going to get 2 every time. And so the last ones. And so when you see that, then you know that those are proportional relationships. So that one would go into this box here. All right, the other table we have is this one where x is 0 and y is 2. And the giveaway on this one is this point right here. If x is 0, then y has got to be 0 for it to be a proportional relationship. So that one would be non-proportional. And you can do the y divided by x on that one as well. All right, the other one are points. So these are our ordered pairs that we have. And again, you can do y divided by x. And so y divided by x here would be 4 divided by 8. When we do that, we get 0.5. So if we do the next one, 5 divided by 10, we get 0.5 or a half. 2.5 divided by 5, and then 6 divided by 12. We get the same constant rate of change every time. So those are going to be proportional points. So if we look at equations in words, so here's our first word problem here. It says the city pool costs $8 per day to visit during the summer. There's also a $25 yearly registration fee. So again, this 25 yearly registration fee, that's telling us that there's going to be something added on or subtracted to the end. So this one would be non-proportional. And then our other words are at HPMS, there are 26 students per teacher in advisory. So again, 26 students per teacher means we're just going to multiply. There's nothing that we're going to add or subtract here. So this one is proportional. And then looking at our equations again, we're looking for y equals kx. So if we look at y equals 2/5 x, we're only multiplying by x. We're not adding or subtracting anything to the end. So same with y equals pi x. We're just multiplying by x. We're not adding or subtracting to the end. So you can see in this one, y equals 1 minus x squared. We're adding, we're subtracting. And then if you look at this one, y equals 4 times x minus 1. If you would work this one out, or if you would distribute your like terms, you would get y equals 4x minus 4. So again, something is being added to the end of that one or subtracted to the end of that one. And then finally, y equals 4 divided by x. And so if you're not sure, you can always graph these and see what they're going to look like. So if I go in here to my y equals, and let's put an equation in. So 4 over x, and we graph this, you'll see how it curves. And so remember, proportional, they have to be those nice, pretty straight lines. So when all else fails, graph the equation on your calculator and see if it curves, see if it goes through the origin. All right, and then finally we have graphs. So again, we want them going through the origin. So graph number 1 here goes to the origin, and it's a nice, pretty straight line. So that one is proportional. Graph number 2 is a nice pretty straight line, but it's not going through my origin. So that one is non-proportional. And then this graph number 2 with the curve, again, it's got to be nice and straight. This one is not nice and straight, it curves. So that means it's non-proportional. And then finally, graph number 7 here is a nice straight line and it goes through my origin. So that is it for this set of notes.